Hey guys, it's just math, y'all. Today we are going to look at the chain rule. This is Cal 1. We're looking at the chain rule. We're going to explore it just a little bit, and then we've got some examples in this series. So let's get started. So, do you remember back in Cal 1, not Cal 1, back in pre-Cal, and you learned about functions? And you learned that you could add two functions, and you learned you could subtract two functions, and you learned you could multiply them, and you learned you could divide them. And what happened when you added and multiplied and divided these two functions is you created technically a third function. Okay, and you also learned how to compose functions. Okay, and created a third function. So let's look at this. Let's just think about this for a minute when it comes to the derivatives. Okay, so let's just suppose that f plus g. Say we've got, I don't know, x to the third plus sine x. Okay, let's suppose f is x to the third and g is sine x. Those are both functions. Now, if I want to take the derivative of this, well, then I just take the derivative of the 3x squared. And if I want to take the derivative of sine x, it's just cosine x. So we have a rule for this already where we can just do, it's called the sum rule. And you just take the derivative of all the little parts added together. Okay? And then we learned how to do the derivative of a product. Okay, so this is two functions multiplied together. So say if I wanted to do the derivative of this, well, then we have our little product rule, right? And that would be the first times the derivative of the second. Derivative of sine is cosine, plus the second times the derivative of the first, which would be 3x to the second. Plus the second times the derivative of the first. There we go. And so we know how to do the derivative when they're multiplied together. And then when these two functions are divided, we use the quotient rule. And so if I had x to the third over sine x, then we would do the low d high minus the high d low. So low times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Okay, so I'm not going to simplify these, but I want you to see that we have learned how to find the derivative of two different functions added, two different functions multiplied, two different functions divided. The sum rule, the product rule, and the quotient rule. Okay, now what we're going to do is we're going to learn how to find the derivative of a composition. Okay, and this is where the chain rule comes in. This is the composition. Some people call it fog and Goff. That's where we plug one function into the other. Fog or Goff. We don't use this notation. I don't see it in the calculus. This other makes a little more sense. Okay, so now if I were to do, if we use the same f and g that we did on these other ideas, f composed with g. Well, f was x to the third, so f would be blank to the third, and then the g goes in here, which would be sine x. Now we would write that as sine to the third x. That's what we would normally write it as, but for the sake of finding the derivative, okay, the chain rule says do the derivative of the outside function, multiply, and then multiply by the derivative of the inside. That's kind of the gist behind the chain rule. So that would be, do the derivative, so it would be 3 blank to the second, right? And so that would be sine x times the derivative of sine x, which would be cosine x. So we've got the derivative of the inside function. That's how we do that. And then if we switch it around and do the g first, remember g is the sine of something, and into the blank goes x to the third. That's the f. Right? And if I want to do the derivative of this, I do the derivative of the outside function, which is the f, which is the sine. The derivative of sine is cosine times the derivative of the inside, which is 3x to the second. Now maybe in this next slide it'll make a little more sense when I use the, and maybe not. But the idea behind the chain rule is that when doing the derivative of a composite situation, you do the derivative of the outside, that was the outside, times the derivative of the inside. So we do the outside prime times the inside prime. That's basically what you do. Let's look at the next slide, see what I have here. Okay, so now just kind of reminding what a polynomial, now I'm not giving you a problem like this, this is just comparing. Okay, this is just comparing, all right? And so just to kind of compare, to kind of get a little feel about this, all right, I've got two functions, they're both polynomials. If I compose them, okay, if I compose them, I'll let g be the red function, all right? So here's f, it's the black function. This is f, and f is 2 blank squared minus 3 blank plus 7. So if I compose them, I put the x squared plus 5 in here. All right, now, if I simplify this all the way out, let's see what happens. This is going to be fun. Yeah, this is going to be, I've already done it. So simplify this all the way out. Whoa, did not mean to do that. Sorry. I am going to, first of all, I'm going to do 2 times x squared plus 5 times x squared plus 5 minus 3x squared minus 15 plus 7. All right, I'm going to FOIL that out. I'll get x squared plus 10x plus 25 times 2. Multiply that out. Minus 15 plus 7. Now I'll combine my like terms. That's not right. That's an x to the 4th. Hold on. And that's x squared. Hold on. Got screwed up. Let's make sure I did it right. That's what happens when you go too fast. Okay. So now I'm going to combine my like terms, and I'll get 2x to the 4th plus 17x to the 2nd plus 42. All right. Now, this is h. This is my h of x. This is my new function that I created by doing the composition of f and g. This would be a pre-cal type problem where you had to take two polynomials and do composition with them. And so now, just to show you that the chain rule really does work, and it actually does make things a little bit easier, I'm actually going to do the derivative now of this h of x. This h of x derivative, just 2x to the 4th, would give me an 8x to the 3rd plus 34x. That would be the derivative of it. Okay, now let's do the derivative of this function using the chain rule. It's a little bit easier. I have left space and hopefully won't make any mistakes. But again, just to remind you that this is the composition, and the inside function is the x squared plus 5. That's the inside function. And so the derivative of the composition is the derivative. Let me look at it, show it to you. So I thought I wrote it down somewhere, but maybe. Yeah, there it is. Okay. So really, it's the derivative of the f function times the derivative of the g function. Okay, it's kind of confusing. Let's watch it. Right? So now the derivative of the f function would be 4 parentheses minus 3, wouldn't it? You do the 2 times that. There's your parentheses. Subtract 1, give 1. And over here, just 3. All right. And then if I put the x squared in there, which I'll do. And now this has to be multiplied by the derivative of x squared plus 5 right here. This would just be 2x. So then after you do that, just do the derivative of that. Well, let's simplify this out. Oh, I just didn't do that the way I wanted to. Hold on. So 2 times 2 is 4. My bad. 2 times 2 is 4. And then times the derivative of the inside function minus the derivative of this is 3 times the derivative of the inside function. That's the way I wanted to do it. Okay, so that's going to give me 8x times x squared plus 5, which is 8x to the third plus 40x minus 6x. Hey, guess what I'm getting? I'm getting the same thing. Well, duh, I should. I use the chain rule. So the purpose of this slide is just to compare, to let you kind of see that the chain rule is developed through the composition of functions. And so anytime you can look at a function and see that it might have been a composition of something, an inside function or outside function, then this is what you're looking for. Okay, you're looking at insides and outsides, and the inside function, that's the one that we want to look out for. Okay, and you can do it. You could actually do the composition and then take the derivative, but sometimes you can't do it. Remember, polynomials are the easiest functions to deal with. Or you can take the derivative as is and just remember to multiply by the inside function. Okay. All right. So I'm going to come back in just a minute and do some examples, a little more examples. So come back and see me in just a minute.